Hello, I'm Dr. Muscle, and in this video we'll be discussing Venn diagrams. So Venn diagrams again it's another instance of something that can appear tricky and difficult at first, but the more practice you get employing them and using them, the easier they get to construct and sort of figure out. And they're very handy, as we see towards the end of the chapter. They're very handy in terms of determining the validity of deductive arguments, particularly categorical syllogisms. So we'll get into that as well here in a moment. The first thing we're going to do is sort of cover some basic conventions in terms of Venn diagrams and how they work, specifically shading and X's, what exactly do those mean when you see them on a Venn diagram. And also want to point out, I guess I could start by saying the circles, right, they indicate or represent classes or categories of things. Again, this can't be just one thing, it's got to be a group of things. We talked about that in the last video. So it's more than one member. And a working assumption that we always have, at least in our class, and as they pointed out in the textbook numerous times, is that these classes will not be empty. There will always be at least one, if not more, members in each category or class. So that assumption is important to note because using that assumption, then we can infer a lot more things from a diagram than we could otherwise. So again, some basic conventions. Let's talk about shading and X's and what those mean. So you'll see up here I've got 4 spots for our 4 standard form claims. We have the A claim, all S or P, the E claim, no S or P, the I claim, some S or P, and then the O claim, some S are not P. And so we'll go ahead and shade those using the Venn diagram. So in each of these standard form claims, we have 2 classes or categories of things represented, hence the 2 circles for each of the diagrams. So all S or P, the way we're going to represent that in this illustration in the Venn diagram is we need to employ shading. Shading indicates exclusion, right? So wherever you see shading, that means there's no member in that area, right? So all S or P, what that tells us is that it's not possible to be an S, right, and not at the same time also be P. So we know there's going to be no members in this portion of the S circle, right? All members of S are also going to be P. So we're going to go ahead and shade the portion of the S circle that doesn't coexist with the P circle, right? So what this tells us again is that any member of S is also a member of P. Right? Hence, all S are P. Okay. So we're also going to employ shading when it comes to an E claim, except this time we're going to shade a different portion of the S circle. So in this instance, we are told that no S are P. It's not possible to be an S and at the same time be a P. So what we're going to do is go ahead and shade this portion of the S circle, which then symbolically represents or illustrates, right, that it's not possible to be an S and at the same time a P. Any S is not going to be a P, hence no S or P. Okay. Now for our I and O claims, that's where we get into employing the X's. Okay. So some S are P, the way we represent that is we need to draw an X. Namely, we're told that, hey, look, there might be tons of members of the S category, right? And some of them might not be P's, some of them might be P's, but we're told, in fact, some actually are P's. Some S are P, right? There is at least one, perhaps 10 million members of the S category that are P. So we know definitively that there is at least one member that's an S that's also a P. So hence the X goes right there. That indicates at least one, if not several, if not millions of members are present there. Okay, so some S are P. Hey, look, we know there's at least one member that's an S that's also a P. Okay. Conversely, with the O claim, we're told that there exists at least one member, maybe 10 million, of this S class that are not P, right? There's at least one member out here, okay? There might be some, for all we know, that are also P, but what this is telling us, this standard form O claim, is that there is at least one, if not multiple examples of S that are not P. Okay, so again, shading indicates exclusion. There are no members in that area of the circles, okay? And X means there's at least one member in that portion of the circle, okay? So that is a quick sort of overview of how to illustrate the Venn diagrams, the standard form claims that we've been working with. All right, we talked about the shading and the X's and our working assumption that all classes have at least one member in them. Okay. So with that, we can sort of move forward and do some slightly more complicated things. We can talk about a categorical syllogism. So a categorical syllogism is a two-premise argument, deductive argument, where we have three terms that appear exactly twice, right? So we'll have two premises always and a conclusion, right? All A are B, all B are C, conclusion all A are C. So in this example, right, this is an example of a categorical syllogism. All the claims are in standard form. That's an important point too that I think I forgot to mention there at the beginning. And you have three distinct terms, each of which are mentioned exactly twice. So we can then use, anytime you have a categorical syllogism like this, you can then use a Venn diagram to assess the validity, to determine whether or not this is in fact a valid deductive argument or a valid categorical syllogism. So now you'll notice, unlike our simple Venn diagrams of the standard form claims where we just have two terms, here we're dealing with three terms. So that's going to introduce the notion of three overlapping circles. And here it's important to then note some additional terminology. You've got to commit these to memory. We have what's called the minor term. And to determine the minor term, the middle term, and the major term, you always got to look at the conclusion, okay? That's going to dictate, and you've got to stick with this convention, that's going to dictate how you're diagramming the argument, okay? So you always go to the conclusion. Your minor term is always the subject, the one on the left. So here we have A. Your major term is always the predicate of the conclusion, or the term that appears on the far right of the conclusion. Okay? And then we have the middle term is the one that's listed in both premises, but is not in the conclusion. So in this instance, it would be B. Okay? So we have the minor term, the major term, and the middle term. You got to be familiar with those and know exactly how to diagram a categorical syllogism using those terms, right? So you always want your minor term on the top left, your major term on the top right, and your middle term lowered and in the middle. Okay. So we can go ahead and assess the validity of this real quick, because that's actually all I have left to do is go through some examples. Again, practice, 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 and you'll get the hang of this before in no time, right? So we go up here. The idea with assessing categorical syllogisms or any deductive argument using a Venn diagram is you are going to plot or diagram the premises, and then you don't do anything with the conclusion. All you do is step back and you ask yourself, is this conclusion implied in my illustration or diagram of the premises? If it's implied in what you have as a result of the premises, then it's valid. If it's not implied in your illustration of the premises, then it's invalid. So let's see if this one is valid. All A are B, right? So we know it's not possible to be an A and not also be a B. So all A's are going to overlap with B's. Right? If it's an A, it's also got to be part of this B circle. Then we're told all B are C's. So same sort of deal, right? It's not possible to be a B and not also be a C. So we're going to exclude all portions of the B circle that don't overlap with C. So now we step back and we ask ourselves, in this diagram of the premises, is this conclusion implied? Can we tell simply from diagramming the premises that all A are C? Well, here's the only place where A's can be, and as a matter of fact, it turns out they're all C's too. So this actually would be a valid argument then. The only place it can be an A is also a C, hence all A's are C's. Okay, so assuming these premises are true, the conclusion has to be the case, and that's what you're doing when you assess validity, is you're asking yourself, if I assume these premises are true, does this conclusion have to be the case? Right? You're plotting what it would look like for the premises to be true, then you're stepping back and you're saying, well, does the conclusion have to be true, having plotted the premises? And it does in this instance, so that's why we would label it valid. Hold on one second, let me make sure I've covered all the points I want to other than my examples. Okay, so I wanted to wrap up the video just by going through some more examples here. So bear with me as I write down the examples. So we have a statement, some minor league players are slow. Then we have the next statement, all catchers are slow. And then they want us to conclude from that hence some catchers are minor league players. Now, just intuitively, if we look at that conclusion, some catchers are minor league players, that seems intuitively obvious, right? Yeah, that seems true. But when we're assessing the validity of an argument, it doesn't matter what's intuitively obvious or true. We're asking ourselves, if we assume these premises are true, does that necessitate the conclusion? Does that mean the conclusion has to be the case? And that's what we want to figure out. Do these premises make this conclusion necessary? Okay, so that's what we'll then try to assess. So a couple things here, right? We want to symbolize the terms with just one letter, like they talked about in the textbook. It really makes things easier, right? So we'll use, what do I use here? C for catchers. Okay. S. Now notice one thing I want to point out as well. Slow will not work, right? Remember, in all standard form claims, you can't have just an adjective. It's got to be a noun or noun phrase. So we're going to turn slow into slow players. Okay. And then we'll have, what are we missing here? Minor league players. So we'll have an M for minor league players. Now we'll go back and try to symbolize what was said in standard form claims using just these basic letters, right? So we have some, this would be premise 1, some M are S, right? That's the first sentence here. Premise 2 is all C are S. That's this one. And then they want us to conclude, hence is an indication of a conclusion, right? Some C are M. All right, so we've got this mapped out, right? Our 3 claims. We have a categorical syllogism here. We have 3 different terms that are all used exactly twice, okay? And all these are in standard form. So we can go ahead and start to diagram, right? We know we're going to need 3 overlapping circles. Okay, and we look to our conclusion to see what the minor term is. It's C, or catchers. Our major term is M, or minor league players. Right? And then our middle term is the one that's not listed in the conclusion, which is S, slow players. So we've got it all labeled appropriately. Now we need to go back, right, and diagram the premises. Okay. So one thing they pointed out in the textbook, and this is very important, when you have one premise that's an I or O claim, and the other premise is an A or E claim, you want to simplify things and always diagram the A or E claim first, because that'll reduce the number of spots potentially where you would put an X from an I or O claim. Okay? Because otherwise, if we try to start here, there might be several spots available. We're not as sure where to put the X, whereas we can eliminate spots by graphing or diagramming the A and E claims first. So let's do this one first. All C are S. Right, so we know it's not possible to be a C and not also be an S, right? Or it's not possible to be a catcher and not also be slow. Okay. Now we can go back here and plot some M are S. So we have the M circle, and we're told, hey, some of them are S. Now we have 2 eligible spots, okay? And unfortunately, diagramming that A claim didn't take out, right, one of these spots. So we have 2 eligible spots. Since we don't know definitively, we know there's an M somewhere in this overlapping S, but we don't know which side. We would put the X here then, right on the line. And again, that tells us, hey, there's at least one member that's an M and also an S, but we don't know whether it's here or here. Okay? So now we've diagrammed the premises, we step back, and we ask, does this conclusion follow, right? Does this have to be the case, this conclusion, based on the diagramming of the premises? Okay? Is it the case that some C are M? Well, we don't know that definitively, right? Because this X could be over here, in which case we don't know definitively that there are C's that are M's, right? Now it could be here, but we don't know definitively, right? That X is on the line. So we're not told enough based on the premises to know this definitively. That means, right, the premises could be true and the conclusion could still be false, right? So this is invalid. All right. So let's go ahead and do another one. What's my second one here? All cool people are philosophers. No philosophers are ignorant. Duh. Okay, and thus, no cool people are ignorant. What's one thing you notice right away? We have just an adjective, right? We need to change that when we label our terms, right, and provide a key. We need to make sure we change that into a noun or noun phrase. So we'll change that into ignorant people. All right, so we'll use C for cool people. We'll use P for philosophers. And we'll use I, not for ignorant, but rather ignorant people. And now we're good. So with our key available, we'll go ahead and simplify things, and we'll provide a simplified version of the categorical syllogism here. We're going to always have two premises followed by a conclusion. Right? So what does this map up to? It says all C are P, no philosophers are I, or ignorant people. And then they want us to conclude from that that no cool people, or C, are ignorant people. Okay? And now we're in a position to go ahead and diagram this. Right? We got our three overlapping circles, each circle representing one of the three terms that's present. So we go to the conclusion, right, to find the minor term, which is C, or cool people, the major term, which is the one on the right, or ignorant people in this case, and then the term that's not listed in the conclusion is the middle term, and that's P for philosophers. And now we can go back up, right here rather, and start diagramming this, right? We want to diagram the premises and see if the conclusion is implied in our diagram of the premises. So both of these are A and E claims, so we can go ahead and just start with the first one. Right, whereas if the first one was an I or O claim, like it was in our first example, then we'd skip down and do, what was it, an A claim, right? But these are both A and E, so we'll go ahead and start with the first one. All C or P, so it's not possible to be a C and not also be a P. So all C or P, we're going to exclude all portions of the C circle that aren't overlapping, that's not overlapping with P. And no P or I, so it's not possible to be P and I, right? So we're going to go ahead and shade or exclude the portion of the P that's also I. Now we're told, look, no C or I. So we step back and we ask ourselves, is that the case? Do I see from this diagram in the premises that this has to be the case? No C or I. Yes, the conclusion is indicated by the premises, right? No C or I. There's no portion of the C circle that's also part of the I, right? The only spot left is this one, which is completely outside of I. So this is valid. Okay. Let's do another one. Some cats are not timid. Sounds like an O claim to me. All cats are animals. Therefore, some animals are not timid. Okay, let's go ahead and create a key here. Cats, that's easy. We'll just do C. Okay. Timid, not going to work, right? We need a noun or noun phrase. That's just an adjective. So we'll go ahead and put T for timid creatures. And then the third and final term would be A for animals. So let's go ahead and write out our categorical syllogism here. So we have some C are not timid creatures. Some cats are not timid creatures. Premise 2, all C or all cats are A or animals. And from that, they want us to conclude that some A or animals are not T or timid creatures. Okay. So now we're in a position to go ahead and create our Venn diagram. We go to the conclusion to find our terms, where they should go, that is. So the minor term, the one that's on the left, top left, is going to be the A or animals. T would be timid creatures. That's going to be the major term and appear on the top right. And the middle term, the one that doesn't appear in the conclusion, is C or cats. Okay. Now here again we have an instance where we want to start not with premise 1 but premise 2, right? Because it's going to help us potentially eliminate some spots where we'll put an X. Okay. So starting with premise 2, all C are A. So it's not possible to be a C and not also be an A, or all cats are animals. So it's not possible to be a cat and not also an animal. All right, so we'll represent that by shading the portion of the C circle that doesn't overlap with the A. Okay. So then we go ahead and go back to the first premise. This is an O claim. Some C or some cats are not T or timid creatures, right? So we're told some C are not T, right? So the only position or area left, okay, we've already shaded the rest of this C. This is an example of why we want to start with A and E ones. If we hadn't started there and we were told some C are not T, we could have put it in this spot or this spot, right? But since we know, right, that it's not possible to be a cat and not also be an animal, right, we've shaded all this area. So then when we go to do the first premise, some C are not T, we know it's got to be here, okay? Because this is T. The only other spot left for a cat or C that's not going to be T is right here. So then we back up and we ask ourselves, from these premises, right, diagramming the premises, does this show, does this have to be the case? Some A are not T. Well, we know, given the diagram of the premises, yes, some A are not T. Now, there might also be some A that are T, right? But that's not what we're assessing here, right? We just want to know, is it clear from the diagram of the premises that some A are not T? And it is clear, right? Because of this. This tells us there's at least one member, or 10 million, or anywhere in between. There's at least one member that's an animal and that's not timid, right? So this will be another valid argument. And we'll do one last one and then wrap up the video. So all Patriots fans are smart people. No smart people watch soccer. And that's certainly not true. My son is heavily involved in soccer. So all you soccer fans out there, don't take offense. Hence, no Patriots fans watch soccer. Oops. Okay, now we want to develop a key here that will represent our different terms. So we have P for Patriots fans, that class or category of things. Okay, and we have S for smart people. Okay, and then we'll use W for people who watch soccer. And I would encourage you, as you're doing these on the homework or practicing for the quiz, to be very careful and cautious, right? And take the time to make all this very clear, especially your key. Know exactly what each letter is representing. Okay? So we'll go back up and map this argument according to the terms here that we've used, the letters that we've used for the terms, that is. So we're told all P are S, then we're told no S are W, or people who watch soccer. And then the conclusion is no P, or Patriots fans, are W, or people who watch soccer. Now again, we're in position to go ahead and employ the Venn diagram to assess the validity of the argument. The minor term, top left, P, people who watch soccer, W, top right, that's the major term. And the middle term, the one that's not listed, S, or smart people, that's the lower mid circle. Okay. And both these are A and E claims, so we can go ahead and start with the first one. All P are S, so it's not possible to be a P and not also an S. So we'll shade out, or shade all the portion of the P circle that's not overlapping with S. It's not possible to be P and not also S, because all P are S. Okay. No S are W, right? So it's not possible to be S and W. No S or W. So we'll go ahead and shade this portion. Okay, now we step back and we ask, from the diagramming of the premises, is it clear that no P or W? Well, we only have one spot where there's P's, right? We've eliminated all the other spots, and what do you know? They're not W, right? That's the only position or spot where it's possible to be P. It's not possible to be W. So no P or W, that is indicated by the diagramming of the premises. Hence, assuming these premises are true, and we've already talked about how, look, this isn't true, right? But for the sake of assessing the validity of a deductive argument, you don't care whether the premises are in fact true, right? You assume they're true, and then you ask, does this conclusion have to be the case? And if it does, assuming the premises are true, then you would diagnose the argument as valid, which is the case here. So in this video, we've discussed the basics of Venn diagrams, the conventions that you have to employ for the sake of clarity, right? Shading means an exclusion, and X means there's at least one instance in that area of the category or the circle. We've talked about our working assumption that there's always at least one member in each class or category. Then we went through several examples. Right? We talked about what a categorical syllogism is, and then we went through several examples of employing a Venn diagram to assess, whether or not the categorical syllogism is valid or invalid. So hopefully you found this video helpful, and good luck with your homework and quiz.